So again, they want us to find the inverse function. So let's go through the two steps again to find an inverse function. What do you do? Number one, invert x and y. And remember, f of x is the same as y. So really, then, this equation is saying this f of x, this is really y. So this is saying y equals 1 over x plus 11. That's what it's really saying. And so what are we supposed to do in step number one? We're supposed to invert. So the x will go out here, right? These two trade spots, don't they? The x goes out here, the y goes over there. Everything else stays put, right? We didn't mess with the fraction. We didn't move the 11. We didn't move anything else. Just the y became an x and the x became a y. We inverted the roles of x and y. That's step one, invert x and y. Okay. Step number two. Number two, solve for y. Those are the two steps, and that's all there is to finding an inverse function. Switch x and y, solve for y. Okay, well, that's sometimes easier said than done. How do we solve this? So remember, this is a this is a wall of separation here, and y is over here saying, I want to be alone. Get rid of that. Get rid of all this 1 and 11 and this fraction stuff, and I want to be alone. I'm trying to solve for y, right? So how do we do it? How do we solve for y? Well, we've had this a couple times. I hope this is getting more and more comfortable for you. You put this over 1. When you have 1, like a whole number or a whole decimal, whatever, equal a fraction, you put it over 1 so that they both look like fractions, haven't changed anything. X divided by 1 is still just x. And then you go diagonal, diagonal. You cross multiply. Remember that? When you have two equal fractions, you go diagonal, diagonal, you cross multiply. Okay. So what becomes of it? X times y plus 11 equals 1 times 1. Tracking with me so far? See what happened there? So that was diagonal multiplication, cross multiplication. That's what you do when you have two equal fractions, which is nice. No more fractions, right? No more denominators. Now we need to distribute the x through here. The x goes to the y and to the 11. We get xy plus 11x, and 1 times 1 is just 1. You see what I did there? I distributed the x through the parentheses, x times y and x times 11. Good. Now, this is where it's easy to get lost. And kind of like, wait, what's happening? I'm getting lost. What are we doing here? Remember what we're doing? Solving for y. Here's the y. He's over here now, and he's yelling out. What's he yelling out? I want to be alone. I mean, he's a big baby, right? I want to be alone. I want to be alone over here. So get rid of this 11x. Get rid of this other x so that I can be alone, right? Remember, that's where we're going, trying to get him alone. He's the big baby, trying to isolate him. So subtract 11x from both sides, right? Boom, boom. So then bring this down. X, y equals what? 1 minus 11x. You cannot subtract this. You can't say that's minus 10x. No. Why not? If that was 1x minus 11x, then yes. Yes. 1x minus 11x does equal minus 10x. But you can't do it when it's just a 1. Those are unlike terms, right? You can only add or subtract like terms. They got to both have an x or both not have an x. If you have one that has an x and one that does not, there's no interaction. They just stay as they are. Nothing can be done about it. So just trying to highlight algebra rules as we move on through here. All right, let's finish it up. Last step to get x alone, y alone. Divide by the x. Divide by the x on both sides. So we get y equals 1 minus 11x over x, like that. That good? And then very last step, just cancel these x's. Nope, you can't touch those. Cannot touch those. Let me back that up. And we're done right here. This is our answer. This is the inverse function. Why can't we cancel those? So that is our answer. You cannot cancel the x's because subtraction on the top glues together to a math teacher, can you tell? I can't spell. Together, I can't think and spell. There we go. Because subtraction on the top glues together the whole numerator. Right? It's Costco, Sam's Club, package deal. Pluses and minuses are glue. So this 1 minus 11x says, we're a package deal, thank you. If you want any part of us, I want that x, then you better buy the whole package or nothing. Does that make sense? You have to cancel the whole numerator or nothing. It's all or nothing, like shopping at Costco or Sam's Club. You buy their whole package, 2 spaghetti sauces, maybe sometimes it's 4, all together. You buy that whole package or you buy nothing. You can't buy part of the package. You can't bring your scissors to Costco again, right? We can't say, oh, I just want the X part, thank you. And you might think, well, that X is just multiplied here, Mr. Aaron. Yeah, but that 11 is glued. So the whole numerator is glued. So pluses and minuses, they glue things together, making them a package deal. You buy all or nothing. We can't buy it all, so we buy nothing. It just stays right there. Now you might, one more thing, you might think, well, this is why math is hard, these crazy rules. Well, this is hard, I agree. But I hope you know that math is just following the truth. They're not making it up to be hard. Think about it. How about if you had 4 plus 2 over 2? Now, what is that really? That's really 6 over 2, right? 4 plus 2 is 6, which is really 3, right? 6 divided by 2 is 3. What if you canceled the 2's there? Now it's suddenly 4. See how that's just not true? That's just not right. That's just baloney. You see that? Math is just saying, hey, this is what's true. Letters are just numbers we don't currently know. So what's not true for numbers is not true for letters, right? So math is just observing what's true. What's true can be complex and difficult at times, but it is what's true. And you think, well, you're saying to me, Mr. Ed, if that was times, it would be okay? Yeah, it totally would. Look at it. Look at the truth. What is it really? 4 times 2, 8 over 2. What's 8 divided by 2? It's really 4. So you're saying it's okay? Of course it is. Look at that. If you cancel those out, it's still 4. See how it's true? Times is fine to cancel, but not pluses and minuses. That's just not true, is it? So this is one of the major rules of algebra that people have trouble with, especially if they go into higher math, calculus, pre-calc, calc, things like that. If you get this rule down, it'll help you in a million situations. Pluses and minuses, what rule? Pluses and minuses, adding and subtracting, glues things together, making it a package deal, all or nothing. You cannot cancel part of a plus minus glued package. So we're done right here. Where was our answer? I did all that talk after. Here's the answer. That's the inverse function right there. We're done. It just has to stay that way. You cannot cancel those x's.